this video, we are going to sketch the graph of the derivative of the function when the graph of the function is given. Our first example is this graph. The graph of the function is given here, and we want to sketch the graph of the derivative of the function. The derivative of the function does not exist at 2 and negative 2. Between 2 and negative 2, the derivative is 0 simply because the function is a horizontal line. After 2, we have a straight line. The slope of the line is rise over run, which is 1. And before negative 2, it's a straight line with the slope of negative 1. Therefore, the graph of the derivative after 2 is 1, and before 2 is negative 1. If you look at the graph of the function, y-axis is the line of symmetry. That means the given function is even. By looking at the graph of the derivative, we see the derivative is an odd function. Our next example is this graph. Let's say before negative 1, y equals negative 1. After 1, it is 1. And between 1 and negative 1, y equals x. We want to sketch the graph of the derivative. At 1 and negative 1, the derivative does not exist. Before 1 and negative 1, the derivative is the slope of this line, which is 1. And after 1, it is 0. Before negative 1, it's also 0. Let's sketch the graph of the derivative of this function. The derivative is 0 at negative 1 and 1. After 2, it is positive. Before negative 2, it's also positive because the slope of the tangent line after 1 is positive. Before negative 1 is positive, and between 1 and negative 1 is negative. The function is decreasing here. So the derivative is 0 at negative 1 and 1. Before 1 and negative 1, it is 0. At this point, the concavity of the function changes. That means the derivative of derivative is 0. The graph of the derivative is given in this diagram. After 1, it's above the x-axis, positive. Before negative 1, it's above. Between 1 and negative 1, derivative is negative. And at 0, it is minimum. Before 0, the derivative is decreasing, and after 0, it is increasing. If we use a little bit of our knowledge from functions, We know the given graph is the graph of a cubic function. Maximum of the function is at -1 and 0, and the minimum is at 1 and, let's say, -1 here. The derivative of a cubic function is a quadratic function. Since the graph starts from the third quadrant and ends in the first quadrant, the leading coefficient of cubic function is positive. A is positive. Thanks for watching.